Hello everyone and welcome to Rebel Way. My name is Andrew Sutherland and today we're going to be creating this portal effect. And as you can see, we've got a few elements that are all layered up on top of each other. And I've also included Tommy in this flip book. In the final render I think I'm going to take him out. But the reason I wanted to include him is to really sell the idea of the scale of this effect. For instance, if we were to just have this particle effect, we're not really going to be able to tell much about how big that portal is. Is it small? Is it the size of Tommy? Is it the size of a city? You know, it can be difficult to tell. But when we start layering effects up, like adding debris, adding smoke, you know, that's a trick to help sell the scale of our effect. So if ever you're working on an effect, no matter what it is, doesn't have to be a portal, it can be a water simulation, a pyro simulation. Start thinking about what secondary simulations can I add to this to ensure that the viewer has a solid understanding of the size of my effect. So let's jump into Houdini and let's take a look at the elements. Okay, so jumping into Houdini, you can see that we've got a few layers. We've got our ground. We've got Tommy here, so this is going to be our scale reference. We've got our ground. We've got our particle effect. We've got some sparks with the base of our particles. We've got this forest debris. And we have our smoke samples with dust. Like I said, I included Tommy just because you can really see that the scale of the scene works really well. And if we were to just have the particles, you know, how big is this? Obviously you're not sure, and even if we put a ground in, you know, we're still not totally certain of the scale of this effect. But once we start adding dust, debris, now the scale becomes a whole lot more obvious to the viewer. And like I said, this is a concept that you can use throughout your work. Just always layer up effects, and the more you layer, I feel like the sense of scale, the sense of size is going to work a whole lot better. Especially if you included something that the viewer knows the size of. Like, so for instance, we could maybe populate this background with trees and create a bit more of an environment in the background, or use a plate at the back, and that's also again going to cement this idea of scale. So if we start off in a clean Houdini scene, I'm just going to press D on my keyboard so I can come over to this background and I can make my scene dark. And let's put down Tommy as our reference scale. So there's our Tommy, and let's frame up. Let's just create a camera for now, something like that. And let's create another geo, and let's call this ground. Diving inside, and we just put down a grid. We can make this 20 meters by 20. And we need to increase our frequency because we're going to displace these polygons. So let's put something like 256, something like that. Then let's put down an attribute noise, and you can see we've got this color on here. But we don't want to randomize the color. We want to randomize the position. So if we type in P, we can see we've got this. This is obviously too much, so let's bring down this value by 0.1, and the element size, you can see the smaller the number, the more confined the noise, and we want to just give an overall breakup. So let's just make sure that this is set to 0 centered. That way it's not pushing it in one direction, it's sort of moving it in positive and negative values where it lies. So yeah, and let's make a copy of this, make sure that it's connected correctly, and you see now we're just doubling up. We want to reduce this amplitude, so make it a bit more subtle, and we want to decrease the element size. So let's just added a little bit more high frequency information to our ground. Let's maybe set this to terrain. Let's increase this by 8. Yeah, not really doing too much. Let's do the same for here. Let's just at least set this fractal to hybrid terrain. Something like that, just a subtle difference. I'm going to unlock this here so that we don't change our camera. And we can just take a look at what we've got. Okay, so we've got something a bit more organic. And it's got 2 noises layered up. And yeah, that's fine. We can put down a UV texture node to make sure we got some UVs on here. As you can see, our UV space is pretty large, so let's maybe increase this. So we have, because this is quite a large domain, we're just going to increase these, increase the scale here, and that way our UV texture doesn't stretch too big. And if you want to just test that out, you can put down a UV quick shade, and I have some, so I have a texture here, and I think this is from Megascans, and it's just a sort of ground texture that can sit on top of our ground. And we're going to cover this up. The majority of this is going to be covered up by debris, so we just want something a little, some basic texture on our ground. So the only other thing I want to change, I just want to change this offset. So we're not clipping Tommy's feet. We're not going to see this because like I said, we're going to have debris, but I just want to show that you can offset this noise if you want. Yeah, something like that. And let's just put down a null out here, and we can use this to scatter points. So we can just say out ground. And also, if we want to create a collision out of this geometry, we could also always say extrude volume, something like that. And then we could say VDB from polygons, reduce this, something like that. And we could say outground VDB. Cool. We want to view it out here, so let's put down an out node, an output, and let's just connect that there. Cool. So next up, we're going to actually build the portal. So let's put down another geometry. Let's call this portal, and let's dive inside. So here we can put down a circle. Let's change this to open arc, and let's increase our divisions by 128. So we now have 128 points along the circle. Next we need to do is just transform this up a bit, just above the ground, but a little bit intersecting with the floor. Something like that. Yeah, perfect. I'm just changing my view here. This is sort of ghost mode, so you can see through everything, and this is solid. So we want something like this. From here, we're going to put down a polyframe just so that we can compute the tangent, and we're going to store that in the normals. So let's disable this and just type in here. And if we click on this information and we click on this in, we want to do it just for our polyframe. So let's try that again. And now you can see we're getting this spiral sort of looking thing, kind of like you see in Doctor Strange, or like a Catherine wheel. So we can use this in information in our simulation later. So let's just close that, and let's create some noise. So we can just put down an attribute VOP, connect that here, dive inside, and all we want to do here is put down an anti-alias noise. So this one, we can take the position to position, and then we can just add this, something like that. Let's set this to 3D noise like that. We can increase frequency, or actually lower it. One, expose this offset. So let's just come here and say promote parameter, and then if we come up here, we can just, let's say $F times 0.1. Let's make sure that we click on this time here so that this plays back in real time. As you can see, it's still too fast, so 0.1, something like this. Let's see if what this is like if we to copy this onto the other axis. Cool. We maybe even make this even smaller so it'll go even slower. Something like that is pretty cool. And let's also add some animation in our first few frames. So let's come on to frame 12. Let's set a keyframe here of 1 and then come to the frame 0 and let's set this to a value of 0. Commit change and then we have our portal opening up. Cool. As you can see, our ground is going below 0. And so what we can do is we can import our ground. So let's put in an object merge and let's come back up to our ground. Let's take our surface. Let's copy the link to that. Come over here, paste this here. So now you can see our ground. And what I want to do is I want to transfer the position of these points based on a minimum distance and copy that position to this our ground. That way this is going to deform itself to the floor, and we can do that by doing an attribute transfer, and we can transfer the position. So we can tick on this allow P attribute, and as you can see they all just jump down to the bottom. It's almost like a ray, but we want to set up some conditions. So let's come over to conditions and let's reduce this distance minimum, so until we get just that little bottom part, something like 2.5. Let's put bend here, something like that. Cool. Let's just try smoothing out our position a bit. So let's put smooth. That's just gonna, blur that position a bit. Cool. So next we're gonna put down a DOP network and let's dive inside. So the main thing we're gonna need is a pop solver, a pop object, and a pop source. Let's wire this up quick. On our pop source, let's change this to first context geometry. And if we come over to birth rate, let's come over to this constant activation and let's just say dollar subframe is greater or equal to 12, and so that's going to equal 1 for any values before 12, and then after 12 it'll go down to 1. So you can see. Cool. Let's increase our particle count to 10,000. Set our life expectancy to 10. Let's jitter our birth time in the negative range. Let's see what this gives us quick. And you can see this is pretty sparse. So let's increase our substeps. Let's just make this 8 and 8. Cool, that's better. And let's just make sure that our collisions are in fact working. So we can say static object, and let's put down a merge. Let's make sure that our static object comes in first, and we can just come back up to our ground. Let's copy this path here, dive back into our portal, into our DOP, our static object, and let's just paste this in here. Cool. So let's add some things to make this a bit more interesting. Let's add a pop drag. This is just going to give our particles some air resistance. Let's increase this to 2. And then let's add a pop force. And let's create some turbulence. So let's increase our amplitude to 15. See what we get. Cool. Turn our swirl size to 0.4. Pulse length 2. That's 0.4. Let's see what this gives us. That's quite cool. And let's make a copy of this. So this will be our small turb. This one will be our big. And let's increase this to 30. Swirl size 1. Roughness 1. Let's see what this gives us now. Okay. So our particles are sort of shooting out everywhere. So we want our particles to follow our curve. So let's put down a pop vop. And let's just see what happens if we take the position and export this as velocity. Okay. So let's update this velocity. And then let's take this input, so our first input, which is our curve, and let's add that to the position. So let's say x, y, z distance. Let's take the position. Let's get our tangent. So primitive attribute, and we stored it in the normal. Let's take that, let's link these, and let's add it to the velocity. And let's, yeah. And you can see it's not working, and that's because I forgot to come over here and come inputs and say first context geometry. And now if we click, we can see now we're getting something that's better resembling what we want. It's traveling further and further away from our portal, so we need to take a look at that, and let's see what we can do. Let's first randomize this effect. So let's put down random, and let's take point number, and then let's remap this. Let's set a fit range. This way we can just select some points. So, and let's plug this into the color for now. So let's set a value of 0.2 here and 0.4 here. So you can see our variation, and then let's multiply this down. So we're going to get some variation in our sim. Let's put our multiply before. Cool. I think this is obviously drifting further and further away. So let's mix between our original position and our updated position. So let's put down a mix. So let's take position from here, and let's say minimum. Let's say minimum position. Let's take this from here. Let's take our position from our input, our position from here, and put that in here. Put this in our second input. Update this position. As you can see, it's now conforming too much. So let's see if we turn this down even lower. I see our collision's not working. We'll fix that in a moment. But this is looking pretty stable now. And let's come over to our collisions, and let's maybe just tick on collisions here. Let's go to volume sample, And let's take our proxy volume from here. Ground. Get our surface field. And as you can see now, our collisions are working. So let's run this again. Cool. We can obviously increase our point count. And that's about it for our portal simulation. You can obviously increase your particle counts if you want, and you can experiment. I think the final file, I think the final file might be slightly different to mine, but essentially this is the technique. And of course we'll share both files so you can just check out the differences between the two. From there, let's dop import this. So let's cache this to disk. Dop import. And we want our dop network, and we want our pop, and say fetch geometry. So and take that. Cool. Perfect. So now we've got just our points. We can put down a file cache. I like to make my file caches red, and let's just say explicit, and let's maybe clean up. Let's put down a clean attributes, or an attribute delete. And we want the velocity, we want the age, we want the ID, we want the life, and we can delete everything except for these. So let's take a look. Cool. We can delete this point group. So let's say group delete. Click on delete unused groups. Just put a star in here. Let's make sure our velocity is correct by putting down a trail node. And let's just say post compute velocity, or compute velocity. And then let's put down an attribute VOP. And let's create some color. So let's just compute the length of the velocity. Let's export this to color. Let's put a fit range on that. Squeeze this to something like 10, 50, 25. Let's normalize the age by dividing age over life. And let's just export this as an attribute, and let's call it lifetime. We can also take a look at this by pumping this into the color. So you can see as it starts, it's got a very low value, and then it should come on to 1. Cool. Let's plug this into a ramp. Let's dive outside here and let's set this to let's dive back inside and let's set this range to 2. Let's try 9. Yeah, something like that. That's better. Let's try 8.2. Cool. And then let's set an alpha. So some of our particles will be transparent. Let's call this alpha. Let's take our lifetime. So as they start, they're going to be very transparent. And then they're going to come on. Let's see that without this. Let's put a fit on our random particle. So let's we need to randomize. Let's take the particle number. Let's fit this. Let's just take a look at the color for now. 0.5 and 1. And then let's multiply this. And let's see what this is doing for us. Yeah, perfect. Cool. And of course our color comes from here. Let's click save. And let's jump back out here. And we can now just delete some attributes again. Since the only thing we need now is alpha, our color, position, our velocity. Cool. So just click on delete non-selected, and as you can see, these are attributes that we need. And the last thing we need to do is set a p-scale. So we can just set an attribute randomize. So the p-scale will vary, but we're just going to vary it from a very, very small value. So 0.001 to 0.0025, and of course we're varying the p-scale. So let's just check that. We can put down a copy to points. Let's take on pack an instance, put down a sphere. And this needs to be a 0. And I've just checked the final project. This was the size of the particles, but it was obviously scaled up in the shader or something like that. So for now, if you want, we can just cache this out to disk, and we can put a let's just say wrangle, and we can just add a multiplier here. So we can just say at b scale times equals 10, 5, something like that. But like I said, this was the final settings, so we can just go ahead and cache this to disk. I'm going to save this as particles, Andrew's version, and this is going to pick up the, we don't want the file name, we want the node name. Cool. Cool, so we have our particles and they cache to disk. We can put an out and output, and that's that for our particles. Next up, we're going to be creating some sparks, so let's put down another geo. Let's call this sparks or portal sparks, and we're going to need to put down a null here. I've already done that, called out particles. Let's copy this. Let's dive in here and just put down an object merge, paste that in. So now we're bringing in our particles, and from there we can just put down another pop sim. In fact, let's just copy our pop sim from here. Stop network, plug this in. Let's delete all of these things. You don't need that. And on our sourcing, let's say to change this to points. First context geometry. Our birth, we're gonna delete our function here. We're gonna just set this to 1. We're gonna lower this to about 1,000. I can turn this off. And let's just say life expectancy 2 and life variance 2. Under attributes in the inherent velocity, let's lower this. You're only going to inherit half the velocity amount. And let's just give this a quick preview. Let's turn off guides. And as you can see now, we've got these particles. They're bouncing up quite a bit. So let's come over to our static object. Let's come over to our pop object under physical. Let's set our lower bounce to 0.1, friction to 10, and let's check this out again. Cool, that's much better. Let's just come over to the sleep. Let's just enable this. This means that if there's a particle that isn't moving much, it gets put to sleep. It's no longer part of the calculation. Cool. And the only other thing we need to add is a gravity, because these are still moving quite far away. Let's just put down gravity. Oh, these will fall down. Cool. Cool, and that's it for our sparks. Let's come back up here and let's copy our network. Paste this here. Let's import. Let's make sure that this is importing the right one. Let's call this sparks. Cool. And let's change this to sparks. Out sparks, and let's save this to disk. Cool. Just one mistake I've made here is that we're deleting the color here, so let's just add that again. CD, and we can come in here, remove this. Cool, and let's just save that out again. Cool. So now we have our sparks and our particles. It's looking pretty cool. And now we can move on to the forest debris. Cool. Next up, we're going to take a look at the debris. So let's put down another geonode. Let's call this forest debris. And let's dive inside. Cool, so next up we're going to take a look at this debris. So let's just take a look here. Yeah, this effect that we see here. Cool. So let's put down a geonode. Let's call this debris. We can dive inside, and I'm just going to copy this across. So this is from Megascans, and let me just show that quickly. So if you come over to this Megascans debris area, you can see that there's a pack of debris and twigs, and you can try out. I tried out this a smaller debris, but it didn't really read very well. Something like this, or maybe you could try something like bones. You know, experiments, and what's quite nice is that when you download this from Megascans, they all come in the center of the origin like this, so you can easily copy this onto points. If you don't, you know, if you don't want to, if your debris isn't all at the center of the origin, you can take a look at the final file. There's basically like a for loop that just transforms each piece to the center, but it wasn't necessary in this case because Megascans has already done that for us. And then I also did a lightning tutorial where you can see how I instanced multiple different objects to points based on their ID. So there's more information on that on our Rebelway YouTube channel. Just look for the Star Wars lightning effect. But for now, we've got our debris at the center of our origin, and we've just transformed it down a bit. So before, and then after. And this quick UV quick shade is just reading in the albedo so that we have some textures on our geometry. So, with and without. So the next thing we want to do is we want to put down a connectivity. And this is just going to ensure that each of our pieces has this name attribute. So let's call this debris. If we take a look at that, we can scroll down here, name, and you can see that each one of these pieces has an attribute. Cool. It's set that to primitive, and then you can see it shows up here as debris. And the purpose of that is that we could take something like a grid here, or let's import our floor. So let's go our ground, out ground, jump back here, put on an object merge. Cool, and let's just for now quickly just scatter a few points on here. Let's reduce this. Okay, and then let's put down a copy to points. And as you can see, it's copying that whole bundle of sticks to our debris, but that's not what we want. What we want to do, let's put down a wrangle. And let's say I at debris equals, and let's fit some random value at the point number between 0 and we've got 47 pieces here, so let's do 47. And then on our copy to pieces, let's come over to piece attributes and let's copy that attribute debris. And now you can see that we've got each one of those pieces on our points. Cool. And then all we need to do is create some randomization. So these are all oriented the same way. But if we were to say, let's see, attribute randomize, and let's randomize the rotation, randomize the normal, and let's say from minus 180 to 180. Minus 180 and 180. Cool. We can also attribute randomize the p-scale. So let's put in p-scale. Let's randomize between 0 to 5 and 1. Let's take on normalize. And that looks pretty cool. In the final scene, this was done all in a wrangle, but this is how you can do it in just the attribute randomizers, and the only line of code we need to do is this. But if you wanted to check out the final project, essentially the same thing is being done all in this wrangle, and I just need to enable this. But essentially it's the same thing. And this was called rubbish, but we've called it debris. Cool. So let's just do some improvements here. And what we can do is we can put down an attribute paint. And if we come over here, we can paint. Let's increase our brush. We can draw in this mask at the center of a scene, something like that. We can scatter on the mask. The scatter automatically goes on density, so let's just make this density. If we come over to attributes over here and we just label this from mask to density, let's go to recache strokes. Let's just do it again. As you can see now, our points are just scattered in that mask area. We can add a blur to our density with an attribute blur. Let's make this 100. Let's make sure that we're blurring the density, not the position. That's just going to give us a bit of a fall off. Whenever you drew mask, it's always a good idea to create some sort of fall off. If we were to put down a color node, we can investigate that. And we just say ram from attribute, density, as you can see without this blur, and now with the blur. Cool. So let's just come over to our scatter and let's increase this to 4000. And what we want to do is we want to set some of these as active and some of them as inactive. And we're going to use the simulation. So let's come back to our particles. Let's take this out, particles, and let's dive into the debris, and let's put down an object merge. Let's paste that particles in here, and let's go to somewhere like frame 60, something like that. Let's put a time shift, and let's just delete channels. So now it's just going to be stuck on that frame. So cool. Let's try 60. Cool. And then let's set an attribute on these particles with an attribute create. And let's call this attribute active. It's an integer and points. So now all these points are considered active, and we don't have an attribute here, but so let's copy this here, and let's set this value. Yeah, this one has got a value of 0, and this one we need to have a value of 1. So this one is now active, the value of 1, and this is inactive because it's got a value of 0. And then what we're going to do is we're going to attribute transfer these attributes onto this, and the attribute we want to transfer is active. So now we can put down a color node. We can just view this information by saying attribute from ram from attribute, and we want the active. Delete these, so we've got a ram from. And as you can see here, this is transferring that active attribute to all our points. So we don't want that. We just want to set up some conditions. So let's decrease this threshold. Let's just pin this so we can take a look. Something like 6. And I'm not sure why this is not pinning, but as we can see now, let's just template our portal effect. So we can see that in this area, our pieces are going to be active, and everywhere else they're going to be inactive. Something like that is cool. We come over to our scatter points, and then we can put down a split. And we can take a look at, let's put down a null, our active and our inactive points. So we're going to say at active equal to equal 1, and we delete. Let's take a look. We need to change this to points. Cool. So this is our active, and this is inactive. Cool. let's just put down an attribute delete, keep the position and the normals, delete non-selected, and we need the color, UV. It's cool. Let's put down a connectivity again. Change this to primitive. String and piece. From here we're going to wrap these just so that it's easier for DOPs to deal with. So we can put down a convex decomposition. As you can see how it's like wrapped these pieces to make them just more optimized for simulation. We can call this realism. And from here I'm just going to copy from our final file, so it's exactly the same. It's, you know, it's a multi-solver. We're reading in the forest. This is debris. This is our bullet solver. And then these are our pop forces like we had on our pop simulation, you know, some drag, some spin, some gravity. Here's our ground collisions, so I don't think we need this. Let's make sure this is set up correctly. So if we come over to our ground, let's take our geometry, paste that there. And then let's come on to volume. Use volume collisions. Let's set this to volume sample. And the ground, we can take our ground VDB. Cool. And the last thing we need to do is we need to put down an assemble node and tick on and create pack primitives. And this is what we need for our DOP simulation. Well, and we just need to make sure that we've create a name attribute. Cool. Just our collisions aren't working correctly. So let's dive back inside. I think what we need to do maybe is just initially raise our points a bit. Cool. Let's try now. Perfect. So as you can see here, we've got, these are just how, you know, like our bounce like we did for the particles and the friction. Our bullet solver is doing most of the magic. Here are our settings. These are quite a high sub steps, just so we don't get any collisions. Everything's working nicely. And of course you can always wedge these things out, but this is our axis force. So we're creating a spinning force. As you can see, it's a sphere. This is the radius, and the position of that force can be moved like so. Cool. These are all our settings. Cool. Very similar to what we had before, just some air resistance as per usual. And to make sure that our spinning doesn't, we don't get pieces that just spin like crazy. And then of course our gravity. Cool, that all gets fed into a multi-solver. We have our collisions and then out. Cool. So let's jump back outside. Let's create a DOP import. Let's import our DOP network. Let's mask it with the forest debris. Let's remove the star. We just want the forest debris. And let's say fetch points. Because it's just easier to cache out points. It's smaller, save that to disk, and then we can transfer our geometry onto those points, and it'll inherit the movement, the position, the rotations, etc. So next we just need to transform pieces. Let's put down a file cache. Once again, I like to mark this red. RBD sim points. Let's just cache this to disk. Whoop. I like to say explicit, and let's just put it in the same location as we did our spark. So cool, so I have those points cached, and now we just need to transform these pieces with the name attribute. So yeah, this is creating our name attribute. See, I had that turned off, so I'm afraid I'm probably gonna have to cache this again. Okay, so I've just made a quick change, and I've no longer using this. We no longer need to use this because we're creating a name over here. For simplicity, I'm just going to remove this. So we're creating the name here. So that's our name attribute, and then we're going to transform these based on the name. We don't really need to optimize it. And we don't need this. So everything is all good. Let's just run this again. Perfect. As you can see, all our pieces are moving with our sim perfectly. Great. So here again, we're just caching, and then because our points have the same name attribute as this, they are now being transferred. Then all we need to do is put down a merge, and we can merge our active with our inactive, and you can see our textures are missing here now. So all we need to do is unpack, because these are packed now, and if we unpack them, we can see we're all back to normal. Cool. Save. And if we want, we can save this again out to disk, or we can just put down a null and say out debris. So the last thing we need to do for our simulations is the dust, which we're going to use a pyrosim. So let's put down a geometry, and let's call this dust sim, and let's dive inside. And we need to object merge our ground, and we need to object merge our moving pieces. So let's get our debris, let's copy this, let's paste this in here, and our ground. Let's take this and paste this in here. And then what we need to do is we need to create an attribute create like we did before, and we can call this density, and we're going to make sure it's got a value of 0. And on this one, we're going to give this a value of 1. And then what we want to do is we want to compute the length of this. So let's just say, let's put down a point vop is less than or equal to, and then we're going to make a channel slider, and we're going to call that speed threshold. Then remove point, and let's tick on this, and let's set our speed threshold, and let's just put down an attribute delete. And as you can see, this is not working because we don't have the velocity. Just check. Yeah, we don't have velocity, so we're going to need to trail this and say post compute velocity, and now this should work. Perfect. So we're going to delete everything but our normal position and velocity. So now we've got just those moving pieces, and we're creating a density value on these, and then just like before, we're going to use an attribute transfer. So we can transfer these values onto our ground. The attributes we want to transfer is the velocity and density, and we can put down a color node, say ram from attributes, and let's take a look at the density, and of course we need to come back to our conditions and turn this down. Starting pack 0.1, blend with 0.1, cool. Cool. So from there we can put down a scatter. And tick on density. Let's give it 2000 points. And let's turn off this relaxed iterations. So it's just got a more organic spread. From there we can put down an attribute noise. Let's tick on blend. Use attributes, and we can enter in density here, and we want to noise up the velocity. So if we take a look at our velocity now, we can see we have the velocities on there. I'm going to change this to 0 centered. Under element size we can reduce this to 0.25. We want animated noise, so that moves over time. And under fractal, you can just put this up as 8, 2, and so we got some more randomization and in our velocities. Cool. From there, we just need to rasterize our attributes. So this is going to convert these this is going to convert our point data into volume data. Let's make this 0.2, 0.05, and we're not seeing anything because we need to actually select the density and the velocity. And because these are now layering up on each other, you can see that's the velocity and this is the density. It looks a bit weird. We can just say just visualize just the density. The next thing that we want to do is we want to include the velocity from our portal effects. So let's put down another object merge. And let's get our portal. And let's import that there. And then let's put down another volume. Rasterize attributes, And here we want to rasterize the velocity, and we can set this to 0.2, 0.175. Cool. Coverage can be rare, and let's just normalize. Cool. From there we can put down a DOP network. We can call this dust sim, and our first input is going to be our density and velocity, and our second input is just going to be the velocity from the portal. From here we can put down a sparse smoke solver, a smoke object, and a volume source, and we're going to need a second one for our density and one for the portal velocity. We can just merge those together. Put that into sourcing. This can go out. So let's say source debris portal V, and this one's going to be our first context geometry, and we can say initialize source smoke. That's going to give us a density. We don't need temperature and velocity. Let's click on enlarge to contain fields, and let's come over to our portal. This one we're going to say second context geometry. We can say source smoke, and we just need the velocity. And let's lower this to 0.4 and click on enlarge to contain fields. If we come over to this front frame, we can say close below, so that this is essentially going to work as like a ground. Let's lower it a bit since we have 0.3. Let's lower a bit since we have you know, some deformation on our ground. And let's set the size here 10, 4, 10, and we can raise this up a bit, 1.7. Let's just click play quick. Cool. So we're getting something. So let's just link our voxel scale, copy parameter, and let's link that to this, and let's link it to this, and then our sim resolution for our final scene was 0.2, but while we work on this, let's just multiply this by 2. Cool. Let's increase our max size 6. Let's raise it up a bit. Let's just actually just make this 4 and raise it up once again 1.7. So I've just come over to this ghost other object so we can kind of see some context of our scene. And that's looking pretty good. And we just need to add some micro solvers to you know, break this up a bit, add some dissipation. So let's add some dissipation. Dissipation just means like the evaporation of the smoke. So gas dissipates. We can plug this in here. And let's evaporate the smoke by 0.2. And then what I like to do is I always break up my my smoke simulations with turbulences and disturbances. Turbulence essentially breaks up the volume from within. So it's like it's basically like introducing velocity inside the fog. It breaks it within, and the disturbance is like velocity from the outside. So the turbulence is often used to break up the overall shape, and the disturbance is designed to add detail on the surface. And then I also like to add a gas vortex confinement, which just exaggerates the the swirling motion and the detail in your simulation. So all of this has already been dialed in the final project. And if you want to learn about how to dial in these things, I suggest looking at the small scale flip fluid tutorial, where I showed how to wedge different values, and you can iterate over your simulations and dial in the look. So for now, I'm just going to copy and paste this from the final project, and we're going to put this into forces, but we can take a look at what this exactly is doing. So under settings, you can see we've got a strength of 30. This is the block size, so the size of the detail, and it's been controlled by the speed. So at a lower speed, there's less of this, and at a value of 3, there's more. And that's it for our first small disturbance. Now we're just gonna have a bigger version, same thing, except this has just got a bigger block size. So the details are smaller. The block size is a value of 1, this is a value of 3. So just layering those up, and the strength is turned down a bit. On our small, this is our small turbulences. These are our settings. If you want to visualize that exactly, you can see what this is doing. So these are the settings for the small turbulence and the big turbulence. If you want to visualize that, you can see. And the gas vortex confinement. This is just going to exaggerate our detail. As you can see, this is going to be quite a cool look. So the last thing we need to do is we need to import this so we can cache it to disk. So we need adopt import fields. We can choose smoke. We don't need any of these. We can just cache the density and the velocity. We need to import adopt network, and let's import this here. From there, we can put a post process. And we can convert this to VDB. We can combine volumes. So without this, you'll see like our velocities in 3 different fields. See, like that. And if we tick this on and combine volumes, now it's all 1, which is great. And we can convert this to a 16-bit float. And then if we take a look here, we can see that our velocity is quite a large size, and we don't need to have that much detail in this field because it's not something we see. It's just going to affect our motion blur. So if we want, we can take on resampling, and we can give this a value of 2, and this is going to reduce our voxel scale by 2. Well, it's going to increase our voxel scale by 2. So we're going to have half as many voxels. So if we see here, it is now halved. So this is just a great way to save up disk space. Like I said, we don't see velocity, so there's no need to cache it at high resolution. Then the last thing we need to do is obviously dive in here. I've already done this. We had that multiplied by 2, but just delete that. So we're now running our high res. Let's click save, and let's just copy our file cache from here. So everything is in the same location. I'm just going to paste this and call this dust pyrosim. Link that up, save once again, and save to disk. Cool, so we have our smoke cached, and then all we need to do is put down a pyro bake volume, and we can increase our density by 4. So I've just want to make a few tweaks, and I think we can get some more detail in our simulation. So if we dive in here and we come over to this smoke solver, and we come over to advanced, we can increase our sub steps here. So we can just say minimum of 2, a max of 4, and we're going to weight this towards, and we're going to weight this, and the sparsity, cool, and vection, let's change this to BFCC, and clamped. And this just is going to ensure that this is just and using this algorithm, I find that there's just, you get a bit more detail. It's go with this, and 5, 64, this is the final settings. And I think we should be good. Cool. Cool, so let's just run that one more time. Let's cache the disk and see what we get. Okay, so the last thing we need to do is jump over to stage. So let's just set this back to how it was. And if you come over here and you jump over to stage, this is going to open up our render viewport, and we want to change this to Solaris. And we want to make sure that we set to either CPU or XPU. If you've got a good graphics card, you can take on XPU, but I'm going to use this CPU for now. And I want to look through camera 1. If we look at our graph here, it's quite simple. But essentially we're importing our ground. So this is like like an object merge, but in Solaris. And all it's doing is a SOP import, and we can come over here and we can say like out ground, copy that, come back over here and just paste that in here, and we're reading in the geometry. So we're going to want to do that for all our effects. So we've got our ground, we've got our tall grass. So here we're reading this, and this is an asset, I believe, from Megascans. We're just cleaning up the attributes, we're seeing the normals, we're transforming it into place, we're adding a path name and an out. So we're doing that for each one of these because we got slightly different grass. So just some variation, grass 1, grass 2, grass 3, grass 4, they're all the same, merging those together, and then we instancing them on this grass instancer. So on the grass instancer, we got an object merge, and we're merging in our ground. We're setting a normal, we're setting a polyframe, and we're creating a density like we did before. You know how like we did for scattering our debris. And as you can see, we've painted on a circle, and then we're scattering some 2000 points onto the density, because this paint attribute is called density, exactly like we did for scattering our debris. So we're instanting the grass onto these points, except this time we're just doing it in Solaris. But it's the exact same process that we did earlier. We were scattering our sticks and twigs on our points that we did earlier. From here, we're going to import our simulation. This is of our twigs, our debris. Here we're importing our dust. Here we're importing our particles, our sparks. We're merging those two together. And here we've got a karma fog box. So basically this is just a box, and these are our dimensions, which is going to encompass our scene, and it's basically just a density value. We merge those all together, and then we're going to put down a material library, and if we dive inside we can see our settings. And if you have an issue with the scene, you probably need to just come here and update this file path, and link the albedo, link the roughness, and link the normals, and just do that for each one of these shaders, and they're really all the same. Our sparks are literally just a color going into the emission, and we've got that alpha going into the opacity. Same thing for the sparks. So all pretty straightforward. And then we come over to this material assign, and as you can see we have like our ground, so you can drag ground to here, and we set our material, which is here, to ground, and we do that just for each one of our objects. So with that we should have our textures applied. Here we're just importing a light, and it's just a point light in the middle of our portal, and you can see these are our settings. Not much to see here really, it's just a colored light. Merging that in, and now we're importing our cameras from our scene, so we can come over here. If we select here, they'll show up here now, and we can select camera, and this renders everything out all together, and you can just render it out. But I personally like to just split things out a bit, so what I've created here is just a matte object, and I'm reading in all the geometry that I don't want to render here. And then if I come down to this holdout, I just set this as matte, and then as you can see, so in this case I'm matting out everything except for the grass, the ground, and our debris. And then I've got a render, karma render settings, and these are my settings for this. You might want to tweak these based on your computer, and the same thing goes for the next thing. So in this case I just have my sparks, my portal effects, the particles, and this is obviously being matted out by now the ground, the fog box, and so on and so forth. So this is all set to matte. And same thing again, this time we're just rendering our smoke. And right at the end we have our fog box. And if you want to get your renders even faster, I would recommend maybe coming here, disabling this fog box entirely, and rendering this out separately. So it's not included at all in any of these renders because there's no need for it really. You can just put it all together when you go to composite. But that's it for the rendering. I hope you like something. Please consider liking and subscribing and sharing this video, just because it'll help out with the algorithms. That would be appreciated. Okay, thanks everyone. See you next time.